Alright, so this demonstration is going to be taking something like this, your first project on the Tormach CNC mill, and learning about the computer-aided manufacturing or CAM operations. So the first thing you want to do is go into Google Classroom, and you want to get the entry called HSMWorks Libraries. In addition to that, you need to walk over to our Tormach CNC mill, and you will see on the machine, in the very front, it'll say what version number we're using. What that refers to is what version of library. Because as we change the tools in our automatic tool changer, then we have to update the library. So anyways, I'm going to click this link right here. It says there's an error, so you have to open it in a new window. And then you have to hit the download button, which is right here. And then it'll download. And then you should put that somewhere, like in your H drive. Once it's in your H drive, you'll notice that it has a zipper on the folder, meaning it's compressed. So you have to right-click and extract all. And just hit the enter button. And it's almost done. Alright, so what's in here? Well, basically, you're going to focus on, we have our Tormach mill, and inside of here is something called a post-processor. A post-processor is a blueprint of our machine so that Solidworks can know what kind of machine we're using down to very fine details. If you have the wrong one, you could crash the machine and things. So that's what that folder is. The other folder you should be concerned about is the one libraries. We spent a lot of time doing this. We're up to version 4. So basically this is for aluminum only. The nice thing about this is all of the feeds and speeds for every single tool has been dialed in, maybe not to be the fastest, but to be a safe feeds and speeds. So anyways, that is what that's for. So we got that. And then in SolidWorks, we're going to go over a couple of things. So first thing in SolidWorks is that this thing in the middle is called a coordinate system, and we need to basically, we want to have the lower left corner would be a good spot to have our X, Y, and Z be. Because again, we have to tell the computer where to start, and telling the computer to start in the center of the metal on top is kind of a weird place to find. So what I'm going to do is insert a coordinate system. And I go insert, reference geometry, and I go to coordinate system. And the computer says, hey, where do you want it? So lower left corner on the top. So I'm going to click on this node here. And right now, I'm on the right spot, but the X, Y, and Z is going the wrong way. So, take it back. The X is going the right way. The X is going positive to the right. That's correct. The Y should be going this direction. So if I click on the Y and I click on this button, but I want to click this button. Notice what happens here when I click this. So I want Y to go that way. And Z is up and down. So this is how it should look. Everyone should have it this way. So Z is up and down, X is going to the right, and Y is going towards the top of the screen. All right, and notice right now that it says Coordinate System 1. I could even rename this and just call it My Coordinate System 1. All right, so now we're going to do the CAM operation. So this tab right here is built in now that we have HSMWorks running within SolidWorks. And the first thing that you have to do, step 1, is to click Job. So if you click Job, it's going to recognize your part, and that's good. And I'm going to put zeros. I'm not going to add any work to this, but do make a note though that there is a safety border here of a 1/4 inch. So you have to imagine the vise clamping this piece of metal. We don't want a bit going at like 10,000 RPMs and hit the vise. So the cutters are going to stay inside of this 1/4 inch border, so make sure you design that. But if we didn't have that border, we might add some numbers in here, but in this case we're not. All right, so top to bottom here. So we're doing milling, that's correct. It did this automatically. We put zeros here. Moving right down the list. Okay, so this is important. What kind of coordinate system do you want to use? Well, ours. So hit Use Coordinate System, and then I'm going to click on the one that we made, which is that one right there, My Coordinate System. Then it says machine. Hey, what machine are you using? Well, you're going to have to go to New Machine and hit Load. Then you're going to go to where you downloaded the thing from Google Classroom. And here it is. And here's the photo I want to click. And that's my machine. Okay. It's got my machine in there. And then I'm set. So my job is done. Now, basically, all of your CAM stuff is probably going to be under 2D milling here or drilling. If you wanted to say engrave out like say a mouse with 3D contours, you do this. And this button here might cost another $5,000 for a business just to have that button there. All right, so we go to 2D milling, and basically think of it as a pocket, as it's going to drive the cutter inside of here. That's called a pocket. Whereas going along the contour, we have a bit going along the outside. So let's see how pocket is going to work. So we have to go to our library, and it's important now that you right-click anywhere in this white space, hit Add Library Folder, and then once again go to Google Classroom where you downloaded that. And it was under Drive H and under HSMWorks and under Library and OK. And is this it right here? Let's see. Here it is. So Tormach CNC aluminum only version 4. We have 9 tools in our machine right now. So if you haven't done the chain break, you might not know enough to do this. But so we're looking for mills here. So we have a 1/2 inch and a 1/4 inch. Let's get as much metal taken out with the biggest end mill we have. So we're going to use this 1/2 inch end mill. And let's see what happens. So don't mess with the feeds and speeds. We've already done that for you. Pretty much everything here, HSMWorks does a really good job just doing a lot of it for you. Let's just hit the green checkbox and let's simulate. Oops, sorry, one thing. Yeah, what do you want to contour? Well, I want to click this. Let's see now if it works. So that's what I want to do. Let's see if it works. Let's go ahead and right-click. We're going to generate the tool path so it does some thinking. And now let's simulate it. Let's see if it does it. So simulate. All right, here we go. So hit the play button. Except for this time, we're going to pick a smaller one. Now let's do a 1/4 inch end mill. And just click it we're going to do again. Let's try and simulate it. Oh, that's what. I made a mistake there. Whoops. I have to edit that out and do it again. Pocket. Library. Right. 1/4 inch. So here we go. Click this guy. And the toolpath is already made actually. Or generate it. And then simulate it. Here it goes. It's going to take some time, right? That looks good. Could we just do the 1/4 inch and forget the half? We could, but it'd be better to use a bigger tool if possible. All right. Last thing basically is to do the drill operation. So I go here, I go to drill, and from the library, let's see what my choices are. My choices are a 1/4 inch drill, a 1/8, and these two ones here. So I'm going to do 1/4 inch drill. Just click on my circle there, and let's simulate it. So it's going to go down there. Go down there. One thing I have seen with the drills, if I go to edit it, that sometimes it doesn't always go through the metal. And so we're not going to mess with the feeds again. And so what you want to do is on the bottom, you might consider putting in a negative number, like, or you can also just hit drill tip through bottom. If that didn't work, you could also do a negative number there. So that'll do it. And so that's really, if I simulate the whole thing, here's my big bit, there's the small bit, and there's my two drills. So awesome, perfect. So now I need to post-process it, basically export it out for our machine. So I click the post-process button. And this is important here. It says, what's the configuration folder that you're getting your post-processor from? And the answer is, we're getting it from your H drive. And that's where we got it from. This was the machine that was in that folder. Where are we going to output it to? Let's output it to that same folder. And what are we going to call it? I'm going to call it, my CNC mill plate. I always give a version like V1 for version 1. And I hit post process. Again, it's going to go do now it's a different file extension called it .tap. And it's making the G code right now. And this is the G code. Let's take a quick look at this, but basically it tells you what's going to happen. There's a lot of G codes here, like G54, G64, G50. This is telling the machine to go certain places, get things in order, get ready to mill. But down here, we get into actual milling, and basically there's an X coordinate, a Y coordinate, and a Z coordinate. And if you look at how many lines of code there, look at this. There's tons of lines of code. but it can read these codes very fast. So our code right here is 66,830 lines of G code. So you put this on a flash drive and head over and get help from myself or an aide. And we will always do a dry run. So we will set the Z 1 inch above your work, and you will watch this whole thing go in midair before we actually dive into the metal. All right, so let me know if you have questions. Thanks for watching.